Okay, the function is f of x, which is x squared plus x divided by 2x. The first question is asking us for what x values is the function not differentiable. So we know that the function is not differentiable, number one, when it's not continuous, when it has a corner, because it has two tangents here, when it has a cusp, again because it has two tangents, or if it has a vertical tangent. What is the derivative? One more time. It's the limit of the difference quotient. So this limit is when h approaches 0. So from either side, how do we determine limits from either side? We check the limit from the left and we check the limit from the right. If they both exist, they are the same, right? So a function will not be differentiable if the limit from the difference quotient from the left of 0 and the limit from the right of 0 of the difference quotient are not the same or they don't exist. Okay? So in this situation, I already noticed that the function is not defined at 0. If a function is not defined at 0, it means it's not continuous at 0, and therefore there is no discussion of differentiability. So at x equals 0, f of x is not defined, and that implies, therefore, not differentiable. So I factor out x, I get x plus 1 over 2x, and I simplify. So the simplified form of this function is x plus 1 divided by 2. This is a linear function now, which is always differentiable. But this is not the function in our discussion. This is the function in our discussion, and that doesn't change anything. If the simplified form is linear, is differentiable everywhere, it doesn't matter. I'm discussing that function, therefore it's still not differentiable at 0. In part B, what is g prime of 3? Oh, was it g? Oh, I'm sorry, it was g, not f. Doesn't matter. Sorry about that. So I'm going to stick with f. I renamed it. So first of all, I would like to determine f prime. So what is f prime for this function? Remember, we do prefer this definition or this presentation versus x plus 1 over 2. X plus 1 over 2 is x over 2 plus 1 over 2. And this is much easier to identify what is f prime for this function. What is the derivative of this? What is it? What is the derivative of 1/2 times x? What is the derivative of 1/2? Perfect. So the derivative is 1/2. So then if I'm asked to find f prime of 3, what will the answer be? First of all, is the function differentiable at 3? Yes, it is, because 3 is not 0. And then what will be the answer? Let's plug in 3. What do we get? Of course. So it also is asking us to describe the simplest way to determine this. That's the simplest way. We simplify the function. It turned out to be linear. We separated so it's easier to differentiate. We differentiated it. What does it mean? What does it mean? It means that when x is 3, the rate of change of the function with respect to x is 1/2. Is there anything else? Other questions here? Anything else you'd like to go back to? Anything else? Other questions?
Did you get the one that I sent you through Canvas?
Yes. Through Canvas, not through Canvas, but through my math lab.
Yeah.
Do you have it faster than the time I need to find it, by any chance?
I don't have it ready. It was like an addition error. I hope can with my laptop.
Oh,
So
so
I
there is
created the
no
question, right?
conceptual problem?
Right.
I just have to fix it? I have to
If
fix the,
Please.
yeah. But is there something that I have to
No.
present? Okay, then, yes, I'll take care of it. Very good. Anything else? Anything else? Okay, well, in that case, I would like to move on. We have, this was 1.6. Before we move on to 1.7 and 1.8, and that will be the end of this chapter, I would like to talk about what is the average cost, revenue, and profit. And then we'll move on to the quotient, not the quotient, the chain rule. So average cost, and I like to look at the problem, and I would like you to choose one. The average cost is the cost divided by the number of items. The average revenue, the same thing, R of X divided by X. And the average profit divided by X. From selling X items, of course. Okay, so let's choose anything you like on page 155. Please choose average cost, average revenue, average profit. They're all the same problems from 53 through, let's say, 63. 53 through 63 on page 155, and see how we apply these concepts.
56?
56 it is. Average revenue. Okay, we're given a function, 56. Tongue-tied sauces, they say, Incorporated finds that the revenue in dollars from the sale of X bottles of barbecue sauce is given by R of X. That's the revenue. 7.5 multiplied by X raised to power 0.7. Can anyone tell us what type of function is this? It's a polynomial, yes. It's X is like the base, and whatever 0.7 is the power. Good, perfect. Find the rate at which the average revenue is changing when such and such happens. So we're asked to find the rate of change of the average revenue. Find the rate at which average revenue is changing. So what is the average revenue? By definition, this is R of X over X. This is just the average. We're going to get to the rate of change. So the average revenue is this, which is 7.5 times X to 0.7 divided by X. To make it easier, we copy 7.5, we copy X, and I want to divide these two quantities. I copy the base. What happens to the exponents? Because they have the same base, I copy the base, and the exponents will be awesome. 0.7 minus 1 is negative 0.3. At this point, I determined the average profit. Now I am ready, after I determine the function, I'm ready to find its derivative. So I will say the average revenue prime. Can anyone tell us what to do in order to find the rate at which the average revenue is changing? When I did not finish reading the problem, when blah, blah, blah happens. But I can't plug in something if I don't have the function. I have to what to plug it in first. So what is, how would you handle this? How would you differentiate this? This is the power rule. I will bring down the power. So negative 7.5 times 0.3 times X to negative 0.3 minus 1, negative 1.3. And I think I get 22.5 times x to negative 1.3. Now I can finish reading the problem. Find the rate at which the average revenue is changing when 81 bottles of barbecue sauce have been produced and sold. So now, what do I have to do for the final step?
Plug it in.
When x is 81, then the average revenue, this is how we like to write it, at x equals 81. I just plug it in. I need the calculator for this. So negative 22.5 times, in parentheses, 81 raised to the power, in parentheses, negative 1.3. And I got negative 0.07. Do they say how many? No, they don't say. Oh, four digits should be okay. Negative 0.0743. And I think I have an error here, right? It's 2.25. There are 2 decimal digits. Right? Okay, so 0.0. I need one more 0 in here. Let me write it so for everyone to see. Negative 0.00743. Measurement unit. That's not good enough without the measurement unit. The average, one more time, the average rate of change of the instantaneous rate of change of the average revenue. So this is measured in
Dollars?
per, like
Bottle?
any, per,
Bottle?
yes, or unit. Excellent, yes, yes. So immediately after we produce and sold 81 bottles and sell 81 bottles, the rate of change for the next one, right, per, or moving forward, per unit would be this. Yes.
The answer that you squared off, what was that?
We're talking about,
I think, yes.
I plugged in 81 in the calculator. Is that the question?
What is it? What is that portion?
This,
Yes. What is
the derivative of the average revenue. The derivative of the average revenue. The rate of change of the average revenue.
and the answer they're looking for is what?
And first of all, this is the function, and this is the final answer. How fast is it changing after 81 bottles are produced?
Plug it into X.
81
Plug into
bottles. Yes, yes, yes. 81. Yes, please.
So in real terms, I mean, what does that number mean?
How fast is the
Well, it's negative.
average? Yes, the average revenue is decreasing. Per unit.
They made 81 bottles, they had to make more, right?
So it's a very good question. So when they manufacture 81 bottles, the average revenue changes at this rate. It decreases. The average revenue. Not the revenue per bottle. The average revenue decreases.
So we could still be making money. Just making
Correct,
less.
correct, correct. But that's the average, on average. Yes. Per bottle, it reduces. Which means what? If we go to, it's a very good question. Let's see what happens if we manufacture, it's awesome. Thank you for your question. Let's see what happens if X is 90. Yes, Maddie?
Going back up to the top a little
Yes.
bit, wasn't the 0.3 negative?
Yes, that's why I put a negative in front of 7.5. Correct.
Okay, sorry.
That's okay. Yeah, that's why I cannot put it here because then it will look like I'm subtracting, but I'm not subtracting. These have to be multiplied, that's why I put the sign in front.
Okay.
Better?
Yes.
Okay, perfect. So let's see what happens when you do this with 90 or 100, whatever you want to plug in. Very good question. So negative, what was it? 2.25 multiplied by 100. Don't forget to put it in parentheses. and the power was one more time negative 1.3. So this time at 100, when we manufacture more, it decreases. So it was 0.007. So now it reduces a little bit less, right?
Because it's an exponential.
Because it's an exponential. Yeah, it's not an exponential. It's polynomial. It's polynomial.
Is this right? The shape.
Yes, but I have to see what you plug in. I only plug in to determine the number.
Right.
So as we manufacture more, the average rate of change decreases by a little bit less. And manufacturing more, we make more. Because the average reduces. It gets reduced. It diminishes in time when we produce more and more. Any questions? Okay. Do we need to look at any other problems here from 53 to 62? If you want to choose something else, go ahead. If not, we'll move on and we can come back to other problems.
59.
59, that's the average profit. Okay. I also wanted to point out something. I don't know what you see over there, but if you have a hard copy, the function that I see here is a cost. It makes no sense for the title to be the average profit. You understand? So if you read the function, what do you have there? It's very interesting. What do you have in
Under
there?
59, I have average profit and it shows the cost.
Yes.
Yeah.
So it's an error.
Yeah.
So there are a lot of errors in this book. So be very careful. Has no, right? So the title is wrong. Or the function is wrong. One or the other. So 59, it should not be average profit, but it should be average cost. Or the function in the problem should not be C, but it should be, if the title is correct, P. So yeah, so be very careful. Don't believe anything. Talk to me about it. So unless there is a revenue in there as well. Okay. So that's in this case it's fine. I just sometimes I did find a lot of discrepancies, and I'll point them out to you. I don't remember exactly where they are, but don't, as I said. Yeah, now I see the other one. Okay, in this case it's okay. For this one it's fine. Okay, so in 59 we're given the average. We're given the cost. This is the function cost, which is 4,300 plus 2.1 times x 2.6. Yes, I see the revenue is also given. That's awesome then. That's fine. 65 times x 2.9. And they're asking us the same thing to find the rate at which the average profit per vase is changing when 50 are made and sold.
Can you bring it up?
Oh, yes, of course. So first we have to find the profit, which will be the revenue minus the cost. 65 x 2.9 minus 2.1 x 2.6 minus 4,300. I wanted to put it in descending order. That's our profit. Now the profit divided by x is 65 times x 2.9 minus 2.1 x 2.6 minus 4,300 divided by x. And yes, I will simplify it, separating into three fractions. 65 times x to which power? 0.9 minus 1. Negative 0.1 minus 2.1 times x to which power? 0.6 subtract 1 minus 0.4 minus 4,300 times x to negative 1. Why am I doing this? Here's a question. Would you prefer to differentiate kind of a polynomial function or a ratio, a quotient? If you want the quotient, we can differentiate that. But I'm assuming that you prefer this versus differentiating a quotient. So that's why I simplified it as much as I could. So now we're asked to find this. You understand you cannot put the number in here yet. Is that clear? If we put in 50 in this function, we're going to get a constant. What is the derivative of any constant? 0. So first we have to find the function that gives the rate of change of the average profit, and then plug in the number. So when I differentiate this, I get negative 0.1 times 65, negative 6.5, times x2 negative 0.1 minus 1 minus 1.1, plus 0.4 times 2.1. So this is 4 and 8, but we have 2 decimal digits. X to negative 1.4, and plus 4,300 times x to negative 2. Very ugly functions. I don't know how they come up with them, but quite ugly. Now I can plug in p of x over x prime. Now I can plug in x equals 50. And let's do this with a graphing calculator. Do you want me to show, or we are on the same page? You need me to show with the software, or?
Yes, please.
Yes? Okay, very good. Please say so. So here it is. So negative 6.5 multiplied by 50 raised to power in parentheses negative 1.1. Close the parenthesis, come down from there, plus 0.84 times 50 caret in parentheses negative 1.4. And then the last one plus 4,300. And then times in parentheses 50. You may not need to put the 50 in parentheses. Careful, every calculator is different. I think we looked at your calculator, right? And it didn't work with us with parentheses. So 1.6356, what does this mean? 1.6356, and the measurement unit. And we have to have 2 measurement units. Any questions on this? Okay. Again, since it's price, you can just truncate it to 2 decimal digits. That would be enough, 1.64. But I need measurement unit. And since it's a rate of change, it has to have a measurement unit coming from the top over measurement unit coming from the denominator.
$1 per day.
Yes. Perfect. Very good example. Maybe we should look at also at 62, population growth, and then we should continue. Any questions? Any questions on this? So then the profit after 50 are sold and produced and sold is increasing at $1.64 per unit. Bless you. The average rate of the instantaneous rate of change of the average profit. Okay, so let's look at 62. And in 62, we are given a totally different function, different type. Can anyone tell us what type of function are we given this time? P of t. So 62, P of t is 500t divided by 2t squared plus 9. Population growth. Okay, the population P in thousands of the town of, is it Coyote Wells? I don't know where it is given by this function where t is the time in years. Okay, P is population and t is time in years. Always take notes when you read. Okay, find the growth rate. So this is the population. We want to find the growth rate of the population. What am I asked to do? What do I need to find? In other words, the rate of change of the population. So what is the idea here? What am I after? Very good, awesome. But now we get very careful because this is a function at the top and a function at the bottom. So remember the formula. And also the denominator squared, not differentiated. So the top function prime. First of all, I see 500 times t. There is nothing else like plus 3 or minus 5, so I could put 500 in front. I don't want to mess with it. It's a constant. So this function is the same with 500 multiplied by t over 2t squared plus 9. When I differentiate the constant times the constant can wait. Don't incorporate the number because it just makes it more difficult. So the top function prime, please. How much? The derivative of t. 1 times the denominator. 2t squared plus 9 minus the numerator times the denominator prime. I need to differentiate the denominator. I bring down 2 multiplied by 2. What is the derivative of 9? 0. Very good. So then times 4t. We have to continue and simplify. 500 can wait. 2t squared minus 4t squared is negative 2t squared plus 9 over 2t squared plus 9 squared. Do not attempt to simplify anything. So this was 4t squared plus negative plus 2t squared negative 2t squared plus 9. So that was part A. Part A. In part B, we're asked, find the population after 12 years. The population after 12 years. So what am I asked to find? We're asked to find the population. Yes, please.
What happened to the 4t and the t? How did they
Negative
cancel out?
4t squared plus 2t squared is negative 2t squared.
Okay.
So we're asked to find the population after 12 years. What are we asked to do?
12. In 12 years, you just plug in
Which one?
to the prime, b prime.
One more time. Population after 12 years.
Put in 12 for top.
In which one?
Oh, first one?
Right. So it's P of 12. We're going to find in a moment. Part C. Find the growth rate at 12 years. What am I doing now?
Now you're using the second one.
Yes, P12, P prime of 12. So this is the population after 12 years. This is the rate of change after 12 years. Rate of change of population with respect to time after 12 years. So immediately after 12 years, how fast is the population changing? So let's put these functions in the graphing calculator. One in y1 and the other one in y2. So one more time, P12, P of 12 is the population after 12 years. P prime of 12 is the rate of change of the population, WRT, lazy people write with respect to WRT, time, with respect to time after 12 years. Ready? So let's put both functions in and just plug in 12 and we'll get both answers right away. So don't forget parentheses around the top, although in this case, since it's only one term, it will work without parentheses just this time. and the denominator in parentheses 2x squared plus 9, close the parenthesis. The second function is 500 parentheses negative 2x squared plus 9, close the parenthesis, divide by, in parentheses again, 2t squared, 2x squared plus 9, close the parenthesis, and squared. Can you all see? So if you may possibly omit parentheses, but I know, I love parentheses, so, and maybe they love me too. Okay, so 500 and so on and so forth. Do you all have this? Yes? Almost? Okay. And then just go to second in table and plug in 12. One of them will give us, in Y1, we will get the population after 12 years, and the other one, how fast is the population changing, increasing or decreasing, I don't know. After 12 years. Ready? So we go to second in table and just plug in 12. Oh, I'm sorry. Sorry. Yeah. Okay, second and 12 and plug in 12, and we get both answers right away. So the first one, measurement unit, it says in thousands. I did not write that. It made no sense to have 20 people, right? So I did not write something very important, population in thousands. Very important. So what will you say P of 12 would equal to then? 20,202 people. What will you say P prime of 12? I got negative 1.58 in thousands, right? So what will that be? Negative 1.581. Measurement unit for the rate of change. Excellent. So after 12 years have passed, it appears, if the model is still holds, I don't know, right, 12 years from now. But assuming the model still holds, then the population, people move out or something, decreases per year by 1,581. Any questions for me? Any questions? Okay, so now the next topic, which is the chain rule, 1.7. The chain rule.